covered this much Python in the class. So maybe we should talk about specifically the portion of it on the final exam. Sound like a fair thing to do? Whatever shall we start with? Oh, hey, look, lists. That which did not make it onto the midterm exam definitely shall make it onto the final exam. So let's see, what did we have? We had this list of texts, COP2271C, Introduction to Computation and Programming, and it was 3 credit hours. We wanted to turn this into a list. Now, how did we do that? We converted each one of the names into strings by putting like little postings around them. Yay, that's fantastic. What's the next thing that we did? We separated each one of the list items with a comma. Comma, comma. Excellent. And then we surrounded the list items with opening and closing square brackets. And then over here. Excellent, fantastic. We're almost there. All we need to really do is put a variable here. Variable here equals poof. And we had a variable that now had a list. So I could talk about this variable called prerequisites. And I could pull 3 items: the name of the course, the catalog number, name of the course, and the number of credits. Out of it because it was a list. How cool was that? That was very exciting stuff back in the day. Well, how do you actually access things on a list? The list is simply a sequence of elements, and you use indexes to get the things on the list. You specify which index you want to use, and that's used in the little square bracket thing. Print values, square bracket 5. We'll print. What will square bracket 5 print? Which item on the list will it print? The 6th! Because we start counting from what?
0.
Exactly. Careful. Okay. How do we actually stick stuff onto a list once we have it? Well, we can start out by creating an empty list, which is just square bracket, nothing in there, so obviously that's an empty list. Then we can say variable name dot append, and then things in quotes. So good food, append burgers. Means burger is now on the list good food. If we want to go crazy, we can add more stuff to good food. We can append ice cream, hot dogs, and cake. So now we have a list that actually has 4 things on it. How cool is that? That's really cool. Sometimes, however, we can stick stuff into a list. How do we insert stuff? We've got a list called friends: Harry, Emily, Bob, and Carrie. And we want to insert at position 1 Cindy. So this is 0 and this is 1. So we're going to stick Cindy in there, and then everybody else can move off to the right. Okay? Oh, okay, so we can also insert at the end of the list if we wanted to, and it'll just stick on the end of the list. That's no big deal. How do we find something in the list? Okay, we can say if, quote, unquote, Cindy is in the list friends, then print she's a friend. Fantastic. N equals friends.index Emily. This will actually return the index value of what's actually in the list. So that's sort of a cool thing. And you can do goofy stuff you want to get. Find it more than one place. Don't care about that. How do we get things off of a list? We use our buddy Mr. Pop. We can remove the element at index position number 1 by doing pop 1. So 0, 1, so that means Cindy's going off our list of friends. See you there. Okay, and if we just do pop with nothing, we remove the last thing on the list, which would be Bill. Now he's off our list of friends. And what else can we do? We can also use remove. We can say friends remove Kari, and we don't care where she is, she's just coming off the list. So we can add things to the list, and we can remove things from the list. I dig it. It's powerful stuff. Spaghetti code. What is spaghetti code? This seems like it's an important thing for you to know, because you'll encounter this in every single programming class you ever have in your entire life. What is spaghetti code? It's a mess. Granted, yes, you're 100% correct. But how do we know it's a mess?
Syntax?
Ooh, syntax is fine, because it'll compile. We won't have any problems with that. But what makes code spaghetti? A rich marinara sauce.
Does it involve a lot of duplication in codes that use each other's variables?
No. Good guess, but no. Oh, this is a test question. Y'all sort of screwed at this point, aren't you? I don't know. Should I show you what spaghetti code is? Will that clarify in your mind? Would you be able to retain it for a week? You think? Alright, so here's what spaghetti code is. Okay? So we're talking about like shipping costs and stuff like that. So if it's inside the US, shipping cost is gonna true. Oh wait. If it's outside the US, it's gonna cost you $10 because it's international. If it's inside the US and it's inside the continental US, it's gonna cost you $5. And then there's the question: if it's not inside the continental US, like Alaska, Hawaii, you gotta do some goofy stuff, and poof. Okay, so if it's Alaska and Hawaii, what's gonna cost me $10? So see what I'm doing here? Ooh, I'm over here and reusing the code that I used there. That's spaghetti code. Okay? Don't do it. What you want to do instead is go ahead and add another block that goes like this. What's the definition of spaghetti code to do? Spaghetti code is a messy network of possible pathways through a program. Okay? Basically, you're mucking up your logic is what you're doing. Never point an arrow inside of another branch. See this? This is what we call an arrow. Woo! See this? This is what we call a branch. See, we're pointing an arrow inside of a branch. Bad! Don't do that. That's spaghetti code. It's difficult to debug. It's difficult to maintain. It's a really, really bad idea. So what's a bad thing to do? Spaghetti code. Boolean variables! Boolean variables are good or bad? True or false? Alright. So basically we're talking about logical conditions. Okay, we can store true or false inside of a Python variable. It's the bool data type, which is what we're talking about here. They're not strings, they're not integers, it's a brand new special type of thing. We can do things like failed equals true. If failed, then do something. How cool is that? Boolean operators, because we want to do stuff once we've got these Boolean variables floating around. We got two primary ones. First one is and, the next one is or. Hey, and or, that's cool. So how do these work together? So if A is true and B is true, then A and B is true. Excellent. And if A is true and B is false, A and B is false. And if A is false and B is true, A and B is false. One more time. If A is false and B is false, and A and B is false. Fantastic. You passed your and test. We'll do it again for an or. If A is true and B is true, A or B is true. If A is true and B is false, then A or B is true. If A is false and B is true, then A or B is true. And if A is false and B is false, then A or B is false. Bam! There you go. Exactly. One more tiny little thing to do. If A is true, then not A is false. And if A is false, then not A is true. That's it. That's all you need to know. Boolean operators. That's all there is to it. Okay, you can invert a condition, obviously not. If not frozen, then print not frozen. Cool. Just the opposite of whatever it is. What happens when you call, oh my god, functions. You remember functions. Functions seem to be an important type of thing. Cool, what happens? Well, so we've got a function called round. We pass it a number 6.8275, and we indicate that we want to have 2 decimal points. And then the result of whatever this is, we're going to stick in the variable called price. So we come over here, we pass it off to round does some function computation stuff, and it returns 6.83, and 6.83 gets returned, and bam, that's what's going to get stuck into price. Multiple arguments can be passed to a function. How many values can be returned from a function? One. There you go. Benefits of using functions are reusability. In other words, you've got the code that you're going to use over and over again instead of sticking your code multiple times. Make it a function and just call it a function. Single function can be used in several different programs. Wow, you did a really good job on your bubble sort. Could I use your bubble sort? Certainly, I'll make it into a function that you can call. Okay, and the second reason is abstraction. It just makes your code a lot easier to read. You know, if you're just calling a function, I can understand that. But if I have to go stepping through that function code each and every time, it's going to get difficult. How to create a function? Da-da-da, pick a name. Select flavor. Define a variable for each argument. Yogurt. Okay, these variables are called parameter variables. Have all this information together along with the def reserved word to form the first line of the function. Def, select flavor, yogurt. So here's the definition, which is the Python reserved word. Here's the name of our function, and here's the variable that we're going to be passing into it. This line is called the header of the function. Ooh. Create the body. List of flavors, wild flavors, and list of flavors, print list of flavors, if yogurt, blah, 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 whatever. Okay? Send the result back. Return selection. So whatever's in the variable selection is going to be sent back to the guy who called the function. Cool. How does this all look when we put it together? Def, select flavor yogurt, bunch of code, return, selection, goes back. Okay? Oh, and by the way, everybody has to be indented too, right? Because that's how that all works. Hot diggity. Functions. Functions are your friend. Definition of a function, just for kicks and grins. We've got our header. We've got the name of the function. We've got the name of each one of the parameters that we're doing. We've got the body of it, and of course the return statement at the end. Now, that's all there is to a function. Function parameter passing, yeah, you can doing stuff. When a function is called, variables are created for receiving the function's argument. These variables are called parameter variables. Display the function arguments of the call. Each parameter variable is initialized with the corresponding argument. So it drops in, it's going to take the value of what's coming in. Return values, you know all about those. And we can even put an expression in the return statement if we want to. We don't have to just have a little variable there. We can calculate math and do stuff like that. Scope, oh my gosh. So what's scope outside of an attractive mouthwash? Okay, scope says where a variable exists, right? And normally if you don't have functions, it's no big deal. You make a variable, it exists, end of story, right? But when you create a function, all of a sudden you've got a special little world in which variables exist as long as you're running that function, right? So let's think about this for a moment. Scope of a variable is part of a program in which you can access it. For example, the scope of a function's parameter variable is the entire function. So depth, cube, volume, side length, and we're doing stuff with side length. If I'm not in this function, can I use the variable side length? If I had side length defined outside of the function, and then I had a function that had side length, which one would Python use? Two different versions of the same variable. When it's in the function, which one's it going to use? It's going to use the global one, right? If I make changes to it in the function, do a whole bunch of really stupid stuff with that, is it going to affect the version that's outside? Not always, right? When that function goes away, that local version goes away too, right? Gotcha. A variable that is defined within a function is called a local variable. When a local variable is defined in a block, it becomes available from the point until the end of the function which is defined. Square equals blah, 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 print square, all that sort of stuff like that. Square only exists inside of the function. When I'm done with the function, square is going to vanish. Okay. Scope problems, okay? So here, I've got side length here, and I've got side length here, okay? That's going to cause me some problems, okay? Yeah, so side length doesn't exist outside of it. It exists in here, okay? But if you can run into problems. If you define another version of the variable inside of the function, that's fine. But any changes you make to that variable isn't going to affect the variable if it's outside of the function, right? So if I have a version of it in my main, if I have a version of it in a function, I mess around with the function, the main version doesn't care. It says, mess around all you want, because you're not messing with me. Opening files, reading files. Files are an important way to store and exchange data between Python programs. Okay, I've got in file, open, equals file name, comma, what? What is it? What letter? R. And R means what? Read. Like Sesame Street, isn't it? Today's show is sponsored by the letter R. Yeah, excellent. If we want to do writing, we can do out file equals open, name of the file, and what? For what? Right? See, look at this. Man, you guys are like on top of it. I'm very impressed. Closing a file. Great, so we've opened up the file, we sucked all the data out, or else we pushed all the data out to it. Now we're done with it. The relationship's over. We want nothing more to do with the file. So what do we do with it? Throw it away. Well, we can throw it away if we want. But first we have to close it, right? File name dot what? Close and poof, and we're done, right? Yeah. Poof, that's how they're good. Opening file and close syntax. Okay, we've got open, and put on R, W, close, close, close. Close looks exactly the same as the files you read from and the files you write from. Reading from a file. So we pop it open, then we do line equals in file dot what? Read line. And what does read line do? It sucks in a what? A what? Line. And the line is defined as starting on the left-hand side and going up till the what? No, not the right. Up until the what? Guys, I've really been this long. Guys, I've really been this long. When does it stop? Which is the what character? No! Yes, but what is that character? It indicates what?
End of the line.
No. New line. It's end. New line. Yes, that is correct. Doesn't look that way, but it sounds good. Okay. Starting at the correct position and continuing to the end of the line is encountered. Alright, read line method returns text as read, including new line character. For example, flying circus, first called read line, And we get back flying \n. Remember, we suck in that new line character when we're bringing it in also, right? And then the second time, of course, we get circus with / also. What are you reading? Read line, nothing to no one returns. Oh yeah. When we suck stuff in from a file, what format does it come in as? Float, integer, string. Everything comes in. If we're reading in numbers, we're still going to read in strings, right? Gotcha, all right. So what that means is that everything that you bring in from a file, you potentially have to convert to something else if you know that it's a number. Writing to a file, out file dot write hello world \n. Okay? If we use print, I think print automatically puts the new line character at the end. If we use write, we actually have to put the new line character at the end. All right. Single argument. You can also, oh yeah, you can write formatted strings to files, right? Little %d, %f, all that. Reading lines from a file. Simpler way to do it was reading to a file, put files as though it was a container of strings. For line in file, which is the name of the file, print line. So we can basically suck each line out of the file just using a for loop. Ching, 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 and that'll come in. Split method, we talked about this. So I have a line of text that I read in from a file. I know that it consists of a whole bunch of words. I want to mess with the individual words themselves. I can use the split method. Substrings equals line.split. Substrings is going to be a list. It's going to be a list of a whole bunch of strings. It's going to be separated by commas, so that really much matters. But basically, then I'm going to be able to take a look at all the words I wrote in. This one I'm doing line.split : I'm saying divide it up. Every time you find a colon, break it up, break it up, break it up, break it up. Right? It doesn't be commas or anything else I want. Reading characters. So I can do in file, input file, read, pren1, pren1. And I can suck in a single character at a time from a file. Bring them in, bring them in, bring them in, bring them in. Ooh, sets. We like sets, right? Sets are our friend. Cool. What is a set? It's a container that stores a collection of unique values. Can I put two of the same thing into a set? Ah, that's the key, right? I certainly can put two of the same thing into it, but it won't show up. Cool, all right. Unlike a list, the elements and members of a set are not stored in any particular order. So basically, what is a set? It's like a burlap bag that you put a bunch of beer cans into, and then you put it in the back of a pickup truck, and you go down a bumpy country road. Do you know that the beer cans are in the bag?
Yes.
Can you tell where any particular beer can is at any point in time?
No.
You cannot, but you know they're in the bag, right?
Yes.
Cool, all right. That's exactly what a set is. Operations available, same as you do with math, denominating in a particular order, it's quicker, better, faster. We did our pizza example. Remember our pizza example? We got our cheese pizza, which is creamy garlic cheese and toasted Parmesan. We got pepperoni, marinara sauce, cheese, and pepperoni, and the meat lover has everything under the sun. And we say, great, I want to create a set that contains the ingredients of a cheese pizza. We use the little squirrely bracket, and we use quotes, creamy Parmesan sauce, cheese, and toasted Parmesan. Bam! I've got a set called cheese pizza. It contains 3 items. I cannot tell you what order it's in, because it's a set, nor do I really care. But I know it has 3 things in it. Okay? I can also create a list if I wanted to. Square bracket, square bracket. Now this has an order to it. I know exactly what's in it. But then I can turn it into a set by saying set, and I put the list name, poof, then all of a sudden it turns into a set. Creating and using sets, the way you create a set is an empty set is created by set pren. Okay, that's fantastic. And you can do really cool stuff by saying length of the set will tell me how many individual unique items there are in a set. Is something in a set? Well, fantastic. If toasted Parmesan is in cheese pizza, the set, then tell me something. Otherwise, tell me that it's not there. Sets in order. Okay, let's see. Since you don't have any real order there, you do 4 ingredient in cheese pizza, print in order, print the ingredient, and it'll send out the ingredients, which is great, but there's not going to be any order there. It will print out each and every item there, but you have absolutely no idea what order you're actually going to get it from. Not really a problem, because you can always do sorted. 4 ingredient and sorted cheese pizza, print ingredient. You would then get a list of all the ingredients sorted alphabetically. Adding elements to a set is actually pretty easy to do. Set name, meat lovers pizza dot add, and then you can do mushrooms. So basically whatever was there, poof, now you've just thrown mushrooms into that particular set. Here's the payoff. You ready for it? Set cannot contain duplicate elements. I could add mushrooms once, I could add mushrooms twice, it's got no problems whatsoever. But when I check and see how many times mushrooms in my set, what's it gonna tell me? It's in there how many times? One time. Okay? Set cannot contain duplicate elements. If you attempt to add an element that is already in the set, there is no effect and the set is not changed. The set will not complain if you attempt to add something twice. But it's not going to change what's in the set. Removing elements from a set, you can use discard when you know what is actually there. Okay? Removes an element if it exists. Remove is a different way of doing it, but it'll complain if it's actually not there. Discard attempts to remove it. If it doesn't find it, it doesn't really care. And oh, by the way, if you wanted to clean out the whole set, you can use clear. Just wipes everything out from your pizza set. Set, union, intersection, and difference. Oh, this seems like this is fairly important. This is that basic stuff we did with sets. Remember? Let's go over this real carefully. The union of two sets is when you have like an auto accident and they come together. One set, two set. Union means you're putting them together. So cheese pizza, union with pepperoni pizza results in marinara sauce, cheese, and pepperoni. All the ingredients of both of those pizzas put together. Got it? That's union. Intersection says what's in cheese pizza and what's also in pepperoni pizza. So we're going to get here marinara sauce and cheese. What's missing? Pepperoni. The pepperoni is only in one and not in the other, right? So it's not in the intersection. And the very last one is called a difference. So if I take cheese pizza and I take pepperoni pizza and I say, tell me what the difference is, what's the difference going to be? Pepperoni. That's it. One item, right? That's the one thing that's not on both pizzas. What's a dictionary? Oh, dictionaries. We remember dictionaries, right? Okay, cool. What is a dictionary? So, it's a container that contains associations between keys and values. Keys and values, keys and values, keys and values. Keys are unique, but you can repeat values as many times as you want to. All right, what do we got here? Keys, we've got John, Ann, Mike, and Mary. We've got 15,000, 12,000, and 30,000. I think those are salaries. It turns out that John and Mary both make 15,000, and the other people make unique values. How? That's a dictionary in Python. Dictionary structure is also known as a map, because a map is a unique key to a value, stores keys, values, and associations between them. How do we actually create these things? It's actually pretty simple. So we got a variable name equals, squiggly bracket once again, John, colon, value, comma. Ann, colon, comma, value. Mike, colon, comma, value. Mary, colon, comma, value. Bam! That's a dictionary in Python, right? It's a key-value combination. We'll list each one of them, and we're good to go. How do you actually get this stuff? We say print and salary is the name of the dictionary, salaries, square bracket, and square bracket, poof. Any questions about that? How do you reach into a dictionary and get a value out of it? You start with the name of the dictionary, and then what do you put? Square brackets. And then what do you put? This is the kicker. You put the what? The key value, exactly correct. And it will return what value? The value. I'm getting that 3 times. Whatever. Okay, searching for keys. If Ann in salaries, hey, you got Ann in your dictionary? Then say what her salary is. Otherwise say, I don't know who Ann is. So you can take a key value and say, hey, is this located in your dictionary? And if it is located in there, it'll actually crank out what the value is. Adding and modifying items here. Once you put stuff into the dictionary, you can change it all you want, basically. Salaries, Lisa equals 25,000. So now we just added one more key value pair to our dictionary. Okay? And oh, by the way, after we've done that, if Lisa takes a pay hit, she goes from 25,000 down to 17,000. All we have to do is salaries, Lisa equals 17,000. And we're good to go. It'll override it, right? So the old value is gone and the new value takes its place. Removing items. I want to make my dictionary a little bit smaller. Salaries.pop Mike. It'll look around in the dictionary. It'll find where the key value pair of Mike is, and it's going to reach in and rip it out. It'll be gone. And actually what's going to happen is it'll actually return the value. So whatever Mike's salary is, 15,000 or whatever, that is actually what will come out when we do the pop character saving. We want to avoid removal errors, so generally what you do is you say, if Mike is in salaries, so let's make sure he's actually there. Then let's go ahead and remove Mike. Because we don't want to be removing stuff if it's not actually there. How do you go through a dictionary to figure out what's there? Print salaries for key in salaries. So this is our variable, this is our dictionary. Print key. Pow. We print out all the keys. So we'll say salaries, and then here's our keys. John, Ann, Mike, and Mary. Print them all out. And once again, the order. You know, with dictionaries, we've got no clue what the order is. It's all there, we know that's good, but we don't know what the order is. Okay, so we basically have 3 different ways of doing exactly the same stuff. The first one is using lists. Remember how we define lists with little square brackets and stuff like that? And how we get to stuff, print values, square bracket 5. We printed the item at what location? 6, exactly. We've got sets. Remember we use squiggly brackets to define sets. Everything in this case is defined in quotes. And we do if toasted parmesan is in the set name, cheese pizza, right? And then the last one that we just covered was dictionaries. Once again, you would define a dictionary as a squiggly bracket, but in this case it's key value, key value, key value. Then we have to reference it. What we do is we use the name of the dictionary, salaries, square bracket, and then a key value to reach in and pull out the value for that particular key value. Make sense? 3 different ways. Do basically the same stuff. Oh, what if your functions are in a different file? Remember this? Yeah. So you've written a whole bunch of functions, they're really great functions, you want to share them with your friends. So what you do is you pull them out of your program, you put them in another one, and then you're going to use the import statement to bring them into your Python program. So how does this actually work? Well, we've got this thing called namespaces, and it turns out you've always been going along, you've been operating in what's called the main namespace. Underscore, underscore, main, underscore, underscore. And this is the namespace that just exists naturally. If you pop open a file like extras, and you bring it in, then you just created a brand new namespace called underscore, underscore, extras, underscore, underscore. So now your program has 2 namespaces. And all of your normal code exists in main, and all those extra functions you brought into that file exist in a different namespace called extras, which is important because you want to reference it. What you're going to have to do is you're going to have to put extras before the function name. Extras dot function name, and then you're able to actually use the function. If you don't do that, you're going to run into some problems. You can say, another way of doing this is from extras, which is your file name that contains all your files. You can say import, and then you list out each one of the functions that you want to bring into your Python program. If you do that, then you can just call your functions without having to put anything funky in front of them. Because you've told Python exactly what functions you want to use from that file. 2 different ways to do exactly the same thing. How? That's it. That's everything you need to know about Python to be successful on your final exam. Are there any questions? Just a numb sense of being overwhelmed. Yes! This is your toolbox. Come equipped with your toolbox and you'll do just fine on the final. Our final exam is when? Starting at 8 o'clock. You'll have the full 2 hours to take it. Whoa. Assuming, of course, that you complete your course evaluation form. If you don't, 8 hours would not be enough to complete.